I mentioned this earlier. I brought up getting a call from Jefferson. I had to go pick up my son, so he had a fever, so he's not allowed to go back to school for 24 hours because of the fevers. So I won't be around tomorrow. I know.
Oh, man.
It kind of puts a little damper on what I was planning to do, but no big deal. I will do my best. If I have time later tonight, I'll just make a video and leave the video for the sub to play through for the second part of this lesson. It is really, you should be able to go through most of it, because the second part of this lesson is really calculator based. Okay? And you guys are good at using your calculators.
What about homework tomorrow?
So we'll get there. So in this case here, what we're doing now is we're going to start talking more and more about polynomials. Now, polynomials wind up being, there are some certain rules that are thrown in there with them. And I want to kind of just show you some generic rules for polynomials today and show you something called synthetic substitution. Synthetic substitution winds up being one of the most important skills in this class that you will have learned so far. You can use it for just about everything. They were just, pre-calc kids they had a test not too long ago that if they would have remembered their synthetic substitution rules, they would have aced it, but they forgot and they got things wrong. So anyway, polynomial stuff. Basically what we're looking at as a polynomial is anything with multiple terms that you wind up writing into what's called a descending order. You guys remember when you first looked at polynomials a long time ago? I don't want you to write all of this junk out. Okay? What I want you to think of here is, remember when you learned in Algebra 1 about polynomials, you had ascending and descending order?
Yes.
Descending order is when you started with your highest degree, the largest exponent, and worked your way down. Now, when we have something like this f of x, remember, f of x stands for a function of x. It's synonymous with y equals, okay? What happens is we rewrite that always into a descending order. It's the etiquette way of writing out math problems. You would write it as 5x to the fourth minus 21x squared plus 14. And what I'm just showing you here is that this, in all of this junk here where it says a sub n, x to the nth, and so on and so forth, that a sub n is basically the leading term coefficient.
I ran into a problem on the ACT where it was like f parentheses f and x.
We're going to talk about that here in a second, because you use a lot of function notation in the ACT. There's a lot of it out there. Okay? It says here that 5 value, the number out front, is your leading term coefficient. We've talked about that when we had quadratics. The n value is the degree. What is the highest degree in this polynomial? 4. So this would be called a fourth degree polynomial. Does that make sense?
Yeah.
When we were working with quadratics, those were all second degree polynomials. They were squared. Excuse me. The third degree polynomial would be cube. Sometimes they call it cubic.
Is that when the function is f to the fifth? Like f 5?
Not necessarily. You're thinking of you're thinking about where I'm getting to. We're not quite to that yet. What we're talking about is the degree is the exponent. All right. Also, the last thing that's on here is the constant. The constant's the one without a variable. You guys have worked with constants before. When you had a problem in the past that looked like this, y equals 2x minus 3, what did the constant tell you?
It's a linear equation.
Well, yes, it's a linear equation, but more importantly, what did that constant tell you? The y-intercept. This constant was your y-intercept because x equaled 0 there, correct? You would substitute in for x, you get 2 times 0 minus 3, and your y value was that. So you knew that at 0, y was negative 3. Vaguely remember that?
Yeah.
Well, it works the same way with this. If this is f of x equals 5x squared minus 20x plus, or whatever, plus 14, what's my constant? What's my y-intercept? 14. I know that no matter what, I already know one set of ordered pairs for this function. I know that when x is 0, y is 14. I know that. That constant will always give me my y-intercept. It's a nice little trick to remember. Okay, it's a very nice little trick. All right? Because eventually we're going to graph these. And now you at least know a starting point. Okay. Now, the other part with polynomials is that we use this, and this is where, Zach, this is kind of where you're headed. We use what's called function notation. That's that f of x stuff. What we're going to do here, and for those of you that have taken the ACT and whatnot, or taken a PACT, you might have seen that.
Yeah, it's not a double function.
You're right, and that just means they put it in twice. Okay. Now, what I want to look at here is the following function. F of x is 3x to the 5th minus x to the 4th minus 5x plus 10. What's that? A lot of times the book does that too. I try not to, why mess it? It's just kind of pointless. Okay. I want to figure out what is f of -2. If you remember back in algebra, you might have done some function notation at some point in time. You might have done something like f of x is 2x minus 1, g of x is x plus 2. And you might have had a worksheet that said, what is f of 6? What is g of 3? Remember seeing that before?
Yeah.
What did you do? You solve. So if it said f of 6, which equation did you pick? The f one. Why did you pick the f equation? Because there's an f. It tells you what to do, okay? It's similarly to what we're looking at here. What this is, it's saying take 6, substitute in for x. And it generates y. This is another way of creating ordered pairs. That's what this is. This is what this does. So when we do substitution with polynomials now, it's the same process. So we have an f of -2. What we need to do is just write it out literally. 3 -2 to the 5th minus -2 to the 4th minus, 5 times -2 plus 10. Notice how I wrote that out with parentheses and everything like that around the negatives, and I made it very, very specific. Do that. Now type it in your calculator.
That'll work, Father. Someone else is going to get it.
I feel like if they wait so fast, I just gave up because I didn't.
How's x y? Oh, yes, f of x is synonymous with y. Yeah. Yes, ma'am. You get -92? Everybody else get -92?
Yes.
Show off. She's talking smack. Say show off.
Because I'm sitting here like.
Hey, be careful. There's a large police presence around the school right now, okay?
So do it after.
Okay.
Everybody okay with that?
Wait, is it -92 or
-92.
Okay, so they're right there.
Sorry, this is negative.
Yeah, I'm just going to correct you there.
That must be fun. Now, what if I told you there's an easier way?
Oh, let's hear it.
I would say Harrison, no.
I would say, show us. I would say, don't show us.
Easy with the lines.
So then it was
I know, I turn around, here's Colton, he's sitting there with his phone in front of his face. Then he turns around.
Wasn't me, I'm on my phone.
No, I'm just.
I just checked it.
It
sound like mom.
All right. We just did direct substitution with -2, correct?
Yeah.
I'm going to show you something called synthetic substitution. We're going to use the same -2. F. Okay? Here's what you do. when you're using synthetic substitution, and this is that skill that I was mentioning that is something that's going to, you can do so much with it. It's pretty nice. You can't make waffles, but what I want you to see here is in the original function, does everybody agree that it's a 5th degree polynomial?
Yeah.
When I have a 5th degree polynomial, that means I should have 6 total terms. 5th degree, 4th degree, 3rd degree, 2nd degree, 1st degree, constant. How many terms do I have there?
4.
That means I'm missing some, right?
Yeah.
So here's what happens. And since I'm missing some, I'm going to write this out with what we call placeholders. 3x to the 5th minus x to the 4th plus 0x cubed plus 0x squared minus 5x plus 10. And this is the only time I'm going to actually physically write out the entire equation, because the process for using these placeholders is the same each and every time. And you're going to see that there's an easier way to do this. Does everybody agree that putting in those zeros doesn't change the function?
Yeah.
Makes no difference. But you have to have these in your synthetic substitution in order to make this work. Synthetic substitution, synthetic division, these types of things that we'll be working on within polynomials was developed prior to everybody having these nice fancy schmancy calculators that you can do quicker calculations. This is even faster than using the calculator by the time you type in large polynomials. Here's what you do. First thing you do is you make a little box like that, box-ish, half a box.
Make a box. It's like a big
Is it a box like you?
No.
Now, pull out the coefficients. 3, -1, 0, 0, -5, and 10. All I do is pull the coefficients off of polynomials using zeros for my placeholders. So now, next time we have a problem that is missing a term within the sequence, what are you just going to put there? A 0, okay? What I'm doing is I'm using -2 as the synthetic substitution, so I put that on that side. Okay. Now for the process. You guys like processes. You're good at them because you replicate them.
Like a synthesis, like you say.
First thing you're going to do, first thing you always do is you drop the 3 here. Okay? Now, multiply -2 times 3. What do you get? -6. You write that there. Relax, it's the first time you've seen it. Hold your whining till the end. Add those two together. What's -1 plus -6? -7. Once again, multiply -2 times -7. What do you get? You write it here. What's 0 plus 14? 14. What's -2?
Wait a second. You put it down.
-1 plus -6 is -7. Multiply -2 times -7, I get 14. Yeah, you keep reusing that -2 each time.
The adding goes down, but the multiplying stays up.
Correct.
Okay, that's what I was.
Add down again, you get -28. Multiply together, you get 56. Add coming down, you get 51. Multiply across, you get -102. And add, and dun dun dun.
92. So that was not fast.
It was the first time you've ever done it. Of course, it takes a minute because you didn't know what you were doing.
Now you know.
And knowing's half the battle. Now, in this case, when you use synthetic substitution, you are substituting a value of x and generating a value of y. You are creating, dun dun dun, ordered pairs.
Can we do that for every single number?
It's an input-output box, yeah. You can do this for any number, yeah. You can do this for anything, okay? Let me show you another one.
Understand myself.
Same idea. I have f of x is 2x to the fourth minus 8x squared plus 5x minus 7. And I want to know what f of 3 is. So when I go to write out my little half rectangle,
Thank you.
you're welcome. My 3 comes out here, and I pluck out the coefficients. 2, then what do I put? Good. Then what? 8, then what?
And then 5.
Okay. The 0 has to go there because it has to have a placeholder. Okay.
There's no 0.
You always put a 0 in for any term that's missing, no matter what. Always, always, always.
What if, that's a 4, what's there's gonna be 4 of them?
Remember, fourth degree polynomials have 5 terms. Fourth degree polynomial has a fourth x squared, or x to the fourth, x to the third, x squared, x, and a constant.
So it just depends, okay, so whatever the first one is, tell me how much the degree it is?
Yes,
Okay.
it'll have one more than its degree. Okay? So now drop the 2. What's 3 times 2?
6.
What's 0 plus 6?
6.
What's 3 times 6?
12. I mean, 18. Don't worry.
Now, guys, you'll notice real fast that the math here, the arithmetic, is really easy. And you're going to make a dumb mistake like Ali does. All right, yes,
I
sir?
got 98, is that right?
I don't know, I'm not done yet. I get 30, 35. One thing that I've done today when I got to the 3 times 35, because I'm trying not to use the calculator, is I'm using my brain. What's 35 double?
70.
Jeez, use your calculator. You can easily add 35 to 70, right?
There you go, yeah.
All right. And you get 98.
Yay.
That's what I get.
See how fast that is?
No, I have no eyes.
Oh, and it's the second time you've done this.
I still think so.
The other way.
This process here, guys, this process of synthetic substitution is going to allow you to eventually factor. You're going to be able to factor polynomials using synthetic, we'll call it synthetic division at that point, to find zeros. It's a very easy method. Yes, sir?
Can we ever raise you that method and one of us with a calculator?
Why would you want to do that?
Do it.
Decide which one's faster.
Have fun typing that out.
You want to type all that out? All right, go.
Let's have a race.
Go.
I don't.
Set it right up.
And get around.
Don't make stupid mistakes.
I mean, technically, he didn't even have his calculator out. So.
Don't worry, Boom! You're right!
Oh, you just like wanted the time
That's right. Boom!
You just did a Vicky right now.
I did. I spiked my pen, but I don't want you, so I was spike your phone. I'm gonna spike your phone. Take that!
Should have done that with the calculator.
No, that's my calculator.
No. What this is here, hey guys,
Use Mark.
the function was negative 2x to the fourth plus 3x cubed minus 5x squared plus 2x minus 6, and I was looking for when x equals negative 2. So Ajenko was trying to be, oh, what if I'm so fast and use a calculator? Take that. Well, well, you'll want. I don't, I'm not like kicking a guy when he's down, but all we did here, guys, I just plucked out my coefficients.
And you got right.
And you just got destroyed.
That's it.
Yeah. All right. The process is pretty easy, don't you agree?
Yeah.
Boy, is it also faster than using your calculator if you had your calculator out or if you brought your calculator to class?
I know, let's prove it. Let's prove it.
Well, again, technically, you had about a 10-second head start.
10-second head start, my foot.
All out.
Wanna go again? Oh, you don't have your calculator. Oh, that is sucks for you.
Can we get a 10?
Again, all I'm doing here is plucking out my coefficients. When I pull out the coefficients, then I could drop the first term.
Wait, what?
Wait, what?
Why does it say X? Oh, because I was thinking there was 4.
You were spending too much time on your phone earlier. You weren't paying attention.
No, I
He's
thought
texting his lover.
I thought it said X was 4, and then it said X equals 4.
What?
Update all students and staff that we were on soft lockdown due to information that we received from the DeKalb Police Department about an assault that occurred on the walking path behind the DeKalb County Health Department. The perpetrator is still at large, however, the police have swept the area and feel that students can't be released. We do have a police presence all around the building, so you will see police cars scattered throughout the parking lot.
I really want to
Again, and development. Thank you.
All right, guys, do me a favor. You gotta go. I know you gotta go catch your bus. That's fine. Just pull online. Have somebody text her with the homework problems here in a second. For those of you guys that walk home and all that stuff, make sure you're walking with one more person.
Yeah, I got you.
All right, seriously. We've got a minute here. Let me just finish this one out. We get 8, 5, 20, 24, 98, and 100.
Wait, no, 96.
Made a mistake.
That's why calculators are more reliable.
All right, what we're doing tonight is in section 6.2. It's page 334. Yeah, 334. I want you to do numbers 37 through 46. It is all synthetic substitution. All right? All synthetic substitution. 37 to 46, okay?
I don't know.
When you're doing them, guys, you want to just go right to making that little half rectangle and filling them in, please do so. Also, don't forget, put a 0 for a placeholder, no matter what it is, whether it's the constant or anything, okay?
And then we would feel bad. Tell myself that I should exercise.
I'm sorry. I didn't know I was trying to hit the side of the board there.